Hi everyone, welcome to this series on feature engineering for data science and machine learning. In this video, we will talk about the use of wrapper methods to understand the column significance. So what we need to know before we start talking about wrapper methods, a little bit of Python skill and some fair knowledge about machine learning models along with the evaluation techniques and standard metric that we use in classification and regression. So what is wrapper method is feature selection technique which uses machine learning. And here what we're going to do is we will select subset of features and then run the model, evaluate. So this loop will continue. The wrapper methods use performance of the chosen model. That means we have to use some metric like accuracy or precision or mean squared error depending on the problem that we are having. And wrapper methods are computationally quite expensive because you're going to run the model against the data set and you have to run it iteratively. So compared to other filter methods, the wrapper methods tend to be computationally very expensive. But they also give you better insight compared to other feature selection or other filter methods. So let's take an example here. Let's say we have a breast cancer data set, which is available as part of scikit-learn. And we know there are 30 odd columns, predictor columns in the data set. And it's about classification. And the objective is to find out the best k number of features. So we're going to initialize first with all the column, train the model. Let's say we are using support vector machine using the current data set, that means the all of the columns, evaluate the model performance. For example, let's say we got the accuracy of 0.92. In the next step, we will find out the least important column out of the 30. Let's say this is the least important. We'll remove it from the previous list, and then we have the updated feature list here. Now we're going to repeat it. Okay, so the previous step number 2 and 3 will be repeated here. So this is the iteration. We're going to repeat it until the desired number of column is reached. For example, here we want to get top 3 column. Now we're going to train the final model. After we know the best 3 or top 3, we can train the model and prepare the model for either testing or production. So there are few types of wrapper method. One is forward selection. That means you're going to start with no features, like 0 features in the array. Then you add one by one. So this is forward selection. Now, example of this forward selection. Let me show you this. Let's say we have the data set with these columns, and the target column is outcome. This is a PIMA data set. So the iteration number 1, you're going to train the model with each of this column here, like pregnancies, glucose, blood pressure, and so on and so forth. There are 8 columns, and take one column at a time and train the model. Now we have to evaluate the model performance. So now we have 8 models here. We need to find out which particular model did well or best. Suppose the glucose provides the best performance, so we will pick this column for the next round. So now you have the feature subset, glucose. Let's say this is how the model performance looks like for all the 8 models in the previous step, and the glucose is the best one. Next step is going to be now associate another column with glucose. So you're going to make the combinations here. And then again, the same thing, repeat the previous step. That means for each of the combination, run the model. And let's say glucose and BMI provides the best performance. So that's going to be your subset for the next round. Next, I'm going to repeat it. Now I'm going to go and add one more, feature, and then stopping criteria is stop when the predefined number of features is reached. Now, just the opposite of forward selection, we have a backward selection here. Just the opposite. We're going to start with all the features, and then iteratively we will remove the least important features from the set. For example, let's say we have x1, x2, x3, x4. These are the column, and the outcome column is y. So we're going to initialize here with all the features, then train the model with all the features. Now we're going to find the least important feature out of the four features that we have. Let's say x3 is the candidate column which can be removed. Next step. Now without x3, which is x1, x2, and x4, train the model and evaluate. So essentially, this is a looping process till you get the best three or top three or desired number. So what happens here in the backward selection is you're going to start with all the features. So let's say you have A, B, C, D, this column. Now we will run with all the subsets, and this subset is A, B, C, B, C, D, A, C, D. These are subsets of the previous four. And let's say this is the one which did well. Then again, you make the subset out of A, C, D. And then let's say this is the best one here. And this process will continue till we reach the desired number of features. I'm going to repeat it now. The whole process will be repeated. Identify and remove the least important feature. And again, the iteration 3, same thing. Identify and remove the least important feature. And stopping criteria, stop when the predefined number of features is reached, or you have a satisfactory model performance. Let's say you are interested in the best, accuracy. So it's going to return the combination of features which gave the best, model performance. Now, with that knowledge, you can further, decide which column to keep, which one not to keep. Now, wrapper method, another variation is the recursive feature elimination. One of the drawbacks with the backward selection method is computationally very heavy, because it's going to start with all the features and then recursively remove one, and then essentially runs all the combinations. The slight improvement to the backward is called recursive feature elimination. How does it work? Let's say you have x1, x2, x3, x4, and the outcome is y. So we're going to start with all the features here and then train the model. Let's say you got the accuracy of 0.75. Now feature ranking is required here at this step. Let's say you ran random forests, and the random forest provides you the feature importance, and then you rank it. And after that, drop the column which has the lowest rank. Let's say x4 is the lowest rank. You drop it from this. Now you notice here we are not creating all the combinations of the subset. Essentially, we just remove it and then run this particular combination and then repeat the process over again. The same stopping criteria, which is reaching the best number of features that we want. So recursive feature elimination, you're going to start with all the columns, and let's say column A is the poorly performing column. Then next round, you're going to run without A, and then again, let's say D is a poorly performing column. In the next round, you're going to run with B and C. This is the essence of recursive feature elimination. I'll show you the Python code here, how it is implemented in Python using scikit-learn. Yeah, so this is an example here on sequential forward selection. And in this, I'm going to take a either decision tree classifier as a model, and you need to install MLXtend package, which has the framework for wrapper algorithm. It's called sequential feature selector. And the data set is going to be breast cancer data set. There are 30 odd columns. And yeah, so you can do a train test, but not required. You just need the data and decision tree classifier, run the selector. Here you're going to mention forward is equal to true. That means you want in the wrapper method to work in the forward direction. And the mechanism for checking the best model is accuracy here. You can also go for cross validation, mention five-fold or tenfold to get a better, metric. Now, this fit method is for providing the data, and essentially is going to run the algorithm on our behalf in the background. So this is what is happening here. It's going to take about some time to execute, depending on the amount of data set and the number of columns and choice of machine learning algorithm. You notice here, how the execution happened here. Let's say the step number one is found this particular column. Step number two is found. You notice here the number of columns is two, and then the three, then four, and likewise is going to execute for all the 30, and then you can get the best performing features as well. So these are the columns which provided the best model performance. So let me show you then the backward selection method, which is this one. Now the here there is no separate library for backward. Just change one setting in the forward selection. For example, here if you mention forward is equal to false, that means it's going to be a backward selection here, and pretty much the same thing. And you will see the final output here. So these are my subsets here. Recursive feature elimination, pretty much the same method. Take your data set and train the RFE, and RFE is going to return the indices of the best performing columns here. So this is how the wrapper methods work. I hope you liked this video. We'll see you in the next lecture. Thank you.